This is an alloy 6-spoke wheel in Alibre that I would like to custom configure. Now we often use the equation editor to do that kind of thing, or even configurations. But this is a dynamic design library tool in Alibre that allows you to customize things very specifically so that only valid files can be output. For example, perhaps this is a 6-spoke 6-lug wheel that I would like to make a 5-spoke 5-lug wheel, and all I have to do is change the drop-down number, and when we're done recomputing, the wheel turns into a 5-spoke 5-lug. And perhaps I'd like to reduce the diameter down to a 16-inch wheel. Well, there the diameter is reduced, and maybe I want it to be quite wide. I'll give it a 9-inch width. And there the wheel becomes wider. Now I think I want my bolt pattern to be 114.3 millimeters by 5. And there are center bolt pattern changes. And maybe I'll want to change the offset down to 10. And then I have a center rib option, right? So we can toggle on a support rib if we'd like to add that. And this is just a simple example of the power that dynamic design generation can give. So especially if you're dealing with customers that you want to make sure stay in the correct parameters, we can provide an interface like this to help generate parts that are valid, and with a lot of intelligence built in. I'll go ahead and click Finish, and let's go through how to generate these kinds of library parts quickly and easily. I'll start by making a new part. I'm going to start off by making a very simple part that is easy to follow. I'm going to start by making a sketch on this plane here, and I'll make a rectangle by center. I'll give a dimension here, we'll say an even 2, and a dimension here, I'll go with 3. Now, let's name the variables that we would like to adjust. So here, if I open up my equation editor, I've got dimension 1, which is my 2, and dimension 2, which is my 3 that I've made. So I'm going to call this something like length and width. Then we'll deactivate the sketch, and we'll extrude. Now I'll call this, or I can click on this little f of x here, and here's my 5. I'll call this thickness. I'll give it a value of 0.25. So if I open up my equation editor, right, I've got thickness at 0.25, width and length. So we're going to say save. And once we've saved our part, we can go ahead and work with it in our part library. So first thing we'll do is go to the Library tab and say Add to Library. We get this menu that comes up once we click Add to Library that tells us what our variables are and what we'd like to include to make adjustable. I'm going to include all 3, of course, or we can go with Include All. Now this may seem trivial, but when we have a complex part that has, 100 different parameters, renaming the parameters into what we want allows us to easily pick out the ones that we want to affect and the rest be ignored. We also have this option to show renamed parameters only. So the practice of naming your parameters as you go, I think, is an excellent practice for library parts. We're going to say Next, and now we have options on what we want our user to do when they configure their part. We have this simple text numeric. We also have several other options like value-driven, range-driven, etc. So when I go into simple text numeric, let's say that my thickness is 0.25 and I have certain stock sizes that I want the user to stick to. So I'll put in my 0.25 value, and I'll put a comma and then 0.5, comma 0.75. So if these are the 3 values I want the user to stick to, I simply put them in here, separated by commas, and when we go to configure the part, we'll have a drop-down menu that forces the user to select one of the values that are available. Now let's say that we're very flexible on our width, and we can do almost any value for our width and length. We can say numeric user input for each of these. And notice we have none here because the parameter values that we have are not required. So our simple text numeric input requires certain parameter values, which we've listed here, and otherwise we don't require a value for the user to input their own value. So I'm going to click on Next, and then we have my parts catalog, and I'll go into a subcategory here and I'll add this in. Now that this is in the library, I can click on the Generate button, and a new interface opens up to where I can go to my catalog, my sample parts, and I can see the configurable part that I've just made here. We're going to say OK. And this is what our interface looks like. So we have our predetermined values of thickness here. And again, that was by using the numeric input field. So we can make it 0.75, and we have a real-time update. If for some reason we don't want to have real-time updates, we can unselect that box here. Now with width, I can make this something like 5 if I'd like. And the part is configured at 5. Maybe I'll go 10 here. Right? So we have a number of options to configure our part with. But this is just the tip of the iceberg for our numeric inputs. Let me go back to my part and continue editing. Back in my part, when I go to my library and add it to my library, I'll include all of my variables. Here, perhaps my thickness comes in certain sizes, like before. But let's say that if we choose a 1/4 inch thick piece of stock, the length and width come in predetermined sizes. So I'll come over here to value driven, and we're going to drive the width by our thickness value. I'll click to edit, and if my thickness value is the driving parameter, which it is here, then I can add a little plus and say when the thickness is 0.25, I want the user to only have the option to select 5, 10, or 15 values. I'll add another one, and I'll say when my value is 0.5, or when my thickness is 0.5, I only want the values to be 7, 13, and 22. And when my value is 0.75, perhaps I only want the values of 10, 15, and 30. Likewise, I can do the same with my length, and I can make that value driven. And notice now that I can choose my width as a driving factor as well as my thickness. But leaving it with our thickness, I can make my values say 10 and 13, 12 and 15, and how about 15 and 17? We'll say OK to that. And next, I'll choose my sample parts again, and this will be section 2. So now when I go to generate, I'll go to my parts catalog, sample parts again, and here is configurable parts section 2 that we've just made. So the user interface is a little bit different, right? I have the options of 5, 10, and 15 for my width, but if I change my thickness to 0.5, now I have 7, 13, and 22. So our options for width and length change depending on what our thickness is. And this is great for things like stock sizes and other configurations that we care about. But we also can build intelligence into our model using other methods. I'll go with a range-driven variable next, and that will allow us to customize our part even further. So this is the part that I'm working with. I saved it as section 3 now, and let's go ahead and add to library. I'll again include all, and we're going to specify a range this time, which is kind of like value-driven, but has a few different points. First of all, we want our thickness to be driven by our width and length. And for that, I'll actually make sure to specify that we're going to have a numeric user input on both of these. So the user is going to explicitly tell us what they want the width and length to be, and our thickness will be determined based off of what they input. And of course, this is going to be determined based off of ranges of values for our width and length. We'll start pretty simple, and we're going to say we're going to have width drive what our thickness is, and I'll add a little plus sign to say when our width falls between a range of, let's say 0.0001 to 5, and I again specify my range with a dash, our value is going to be 0.25. Then I'll add another condition. If our width falls between 5.001 and 10, we'll have a value of 0.5. I'll add another condition. If our width falls between 10.001 to 20, we'll have a value of 0.75. And we'll say OK to that. Now I'll say next, but you'll notice something. I don't actually go next, and I get this salmon colored line indicating that there is an error of some kind. So this brings us to some other functionality that is available in this Add to Library menu. I'll take this to move it down, and I'll move my thickness to the bottom. And now when I say next, the error is resolved. So I had my thickness value that was prior or before my width and length, and that registered as an error. But now these values of width and length are recognized because of the order of my variables. We'll say next, and I'll again stick this in my sample parts library. And now I can go to generate. And from my parts catalog, I'll go to sample parts, and there's my next configurable part that I've made. You'll notice that I only have my width and length parameters. So my width is 5. If I make that 3, then we update. But if I make it 5.1, you'll notice the thickness becomes larger. Likewise, if I make my width, say, 15, then we get an even larger thickness. And if I go to 30, then we continue at the thickness that we were. If I say 5, and then I move to 30, we keep the thickness because 30 was outside of the parameters that we set. So if we go outside of our specified parameters, then we just stay at whatever thickness that existed prior to establishing those parameters. Keep that in mind. But we can have an even more complex and robust range values than this. Let's go back and edit our part with some even more specificity. So here I am with my configurable part. I'll click on Add to Library, include all of my variables once again. Here I'll move my thickness down, and we'll have each of these be a numeric user input that we discussed, and we'll make this range driven. We're going to click to edit, and we'll have my driving parameters be both width and length. Right? I'll hold shift and select both of them. Now I have the width and the length and the value. So I can say something like, if my width falls between 0 and 5 and my length falls between 0 and 3, my value is going to be 0.25. Again, and if my width falls between 0 and 5 and my length falls between 3.001 to 5, we'll make that 0.5. And then I can add another condition, right? If my width falls between 5.001 to 10, and my length falls between 5.001 to 10, we'll go with 0.75, and so on. So we'll say OK to that, and we'll say next. We'll put that in the sample parts library, and now we'll generate. And we'll test some of these values and rules that we made. I'll go to my catalog, sample parts, and click on my latest. From here, if my width is 1 and my length is 1, then we have a thickness of 0.25. If my length goes to 3.5, we now have a thickness of 0.5. If my length goes to 9, we still have a length of 0.5, but if my width goes to 9 as well, now we're at 0.75. So it's looking like our rules are working pretty well. And we can have even more parameters than just 2. Range can work across a number of large parameters to establish very robust automatic updates to your part. But let's go back and look at a few other things that we can do to build intelligence and options into our part. Here I am back at my part, and let's add some features to this. I'm going to create a sketch, and let's add 2 pins here. I'll make them symmetric. Axis and the 2 circles so that they're both symmetric. And then we'll make this vertical. We'll give it a diameter. And then I'll deactivate. And then I want to adjust that 1.5 dimension that I've done. So I'll say boss underscore diameter. We'll do an extrude off of sketch 2. Give it a draft angle of 20 degrees. And I'll go a distance of 2. And I'll draft inward. Maybe I'll go a distance of 1. That's a bit better, right? So we've got these sort of drafted bosses on this. Now, let's say that our customer may or may not wish to have these bosses. Well, I'll go into my library. We'll add this to our library. And of course, we'll save. I will show renamed parameters only, which is a great way to filter out the constraints that I don't wish to include. And I'll include all. And now, I'll let the user set the thickness by 0.25, 0.5, 0.75. Our width can be numeric as well as our length. And now with this boss diameter, let's go with 1.5, 1, 0.75. And let's also add a suppression state. This will allow the user to decide if they wish to have these bosses or not. So we'll click a plus over here to add a new parameter, and we'll change this to suppression state. And then we'll click to edit. For our suppression state, I'll click a plus here, and I'll say with bosses. And we'll leave that as do not suppress any feature. I'll click another one and say without bosses. And then, in this column, I can choose to suppress extrusion 2. And with that, I'll say OK. Now, when I go to click Next, you'll see that there's some red text that shows up. What's going on here? Well, I'll need to give this a name. So I'll call it Boss Options, and then I'll click Next. You'll see that I just flagged an error because I needed a name for this. Otherwise, everything was fine. I'll again add this to my sample parts and finish. Now when I go to click Generate, I can select my part. And now I can not only customize my thickness with my drop-down and set a width and a length, but I also can simply suppress my bosses if I wish to not have them. So I can have my with bosses or without version. And these suppressed states can really help your user customize exactly what they'd like to do with the part. But suppression states can also give us a number of other options, and we can go through and see what they have to offer. This is the part that we've been working on, and we can add some additional intelligence to the way that we customize these parts. I'll add a feature on this face. So we'll start a sketch, and let's say that I want to add a slot. And we'll say that in the presence of this slot, we might want to customize some mounting options, right? Maybe this is an alignment part, and we'll want to customize the diameter of these bosses if we have the presence of the slot. So I'll select a midpoint relation. There we go. There we go. And we'll assign this to be a radius of 0.5. Maybe we'll give the slot a dimension here of something like 3. Maybe I'll go with 1, just so it's a little more compact. We'll deactivate the sketch. We'll go with an extrusion through all. So that will be our slot. Let's talk about how we can change sizing options if some features are suppressed. What I'll do first is save, then we'll go into library and we'll add to library. You'll notice we have all these now dimensions. We can show renamed parameters only, and hopefully that shows just how convenient it is to narrow down what we're looking for. I'll go with our boss diameter here. In fact, I think that's all I need for this section of the video. So with our boss diameter, we'll want to add a suppression state. And so I'll click the plus over here, of course, and add in our suppression state. And now I can say, I want my slot showing. And then I can add an option for no slot. And if we choose no slot, we'll of course suppress the presence of our slot. I'll move this down below. Not that you have to, but I just think it's kind of good practice to get an order of things. Right, put our dependencies below. And since our boss diameter is dependent upon if our slot is suppressed or not, I'll have that below, and we'll give this a suppression driven input. And from here, you'll notice that we don't have any information in our drop downs. Let me cancel that. We'll have to add a name here, and we'll say slot option. Now if I click, I have my slot option in my driving suppression state, and here are the features that are suppressed or not in that state. I'll make my extrusion 3 applicable, and of course if I suppress many features, then more features would show up down here. And what we're saying is, if this extrusion is present, then how do we want our user to have inputs? If this slot is present, then we can have the straight up user input, or we can do a drop-down list, which I'll choose, and I'll say, yes, if the slot is present, I'll want to have the option of doing values of 1.5, comma 1, comma 0.75. And then I'll say OK. And then I can click Next, and I can go into my sample parts and finish. Next, let's configure this. So I'll go to Generate. As before, I'll go to our sample parts. There's my configurable slot. And here are some things that are showing. So right now, we have our slot showing and our diameter is at 0.75. If I turn off the slot, then that reduces our options, right? So we show the slot, and all of a sudden, this option comes so that we can adjust what we have. Then if I go back to no slot, then we go back to our default parameters. So this seems to be working as we wish. But speaking of these kinds of holes, we have some threading options as well that should be very robust for users. Let's go through how to do that. And to go through configurable threads, I'll need to make configurable threads. So we'll start by using the hole tool that allows us to assign threads to a hole. And of course, I'll select my start surface here. I can choose a thread series, maybe isofine. That makes me feel pretty attractive when I say that, isofine. And then I'll go with, say, 4.5 by 0.2, right? And I can click to add the holes that I'd like to have and say OK. If I wish to make these a bit more exact, of course, I can go back into my sketch, which is probably a good idea. And we'll make a center rectangle. I can add a coincident relation to each of these points that will be my holes. And using this reference geometry ensures that I have very consistent hole placement. Make this, let's say, 4 by 8.5. And I can add a horizontal, and we'll deactivate. So there we have 4 threaded holes. You can see that we have the cosmetic threads on there. Well, now, if I were to generate or add this part into the library, I'll go to Library, Add to Library. We'll save our changes, of course. We'll go with Show Renamed Parameters Only. And in fact, I'll just go with boss diameter here and allow user numeric input. Let's talk about the holes. I'll add another line, and this time we'll go with threaded selection or thread selection. And when we click to edit, we can see that we have our features that have threads here. So I select my hole 4, and I can select specific holes that I would like to have, or I can select all. Now this is just ISO coarse. I have the option to go to ISO fine and select all. In fact, I can go to pretty much any hole option and select all the holes as options. Now, this is probably not realistic because some of these holes become very large and very small, and you're probably after specific kinds of holes for your part. But I'm doing this to show that you can make pretty much any hole. As you move forward, you may have this error, and that of course is a name error. We'll need to give this a name. And now we'll be able to move forward without an issue. And we can add this into our sample parts. And what does this look like in the user interface when we go to configure this? Well, we can say generate, sample parts, and just like that, we now can choose our boss diameter that updates in real time. We also can choose our hole size, and it updates in real time with whatever threads the user would like to have from the drop-down. So these are the ways that we can use dynamic part generation to speed up our process and make things easier for users. Now we may want to take a look at how we manage our library. So we're going to go, say, back, cancel, whatever, and finish. And then we're going to go to our library tab, and I'm going to grab Manage Library here. Under Manage Library, we can see my entire catalog, and it breaks into certain subcategories. Right here we have sample parts, and that breaks into a folder, my sample parts and my wheel sample. Now I can always create a new library here. And then I can click the plus sign again for a new category. And the plus sign again for a new part collection. And then my plus sign is grayed out because I've gone as far as I can. If I wish to delete the parts that I have worked on, right, I can go to my configurable part and X, and there it's gone. So it's as simple as that. We also can edit a part that we've made, so I can click on this edit button and it brings me right back into my environment if I wish to change some aspects about how I've created this configurable part. Once we make some changes, we can say next, 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 and finish, and our library is updated with any changes that we make. Now we also can use this edit to not just change aspects of what we've done, but we can move them, right? Perhaps I wish to move configurable part 4. We click on edit, it takes us into the editor here, and I click next, next, and I can say, you know what, let's stick this in my new library, in my new part collection. Now, I only go up to configurable parts section 3, and we go into our new part collection, and we're located in configurable parts section 4, so we can move these parts around in between different locations. We have the also ability to import or export, and we can do this with an individual part, with import or export, or we can do this from a whole library. So I can click here, and when I go to export this, it is saved as an AD_LIB file. And then I can import that file in somewhere else. So if you wish to share libraries, even on the Alibre forum, you certainly are welcome to. And so these are the library management tools that we can have when we make our generative parts. I think that about covers what we need to cover for generative parts. Thank you so much for watching, and don't forget to subscribe to the Alibre channel.